Okay, in this YouTube, I just want to go through asymptotes and what asymptotes mean. So first, let's define what an asymptote is. It's a line that a graph approaches but does not reach. But does not reach or touch. Reach or touch or intersect. You get the idea. So if this is an asymptote, the graph is getting closer to it, but it's not quite getting there. It's just this little buffer zone. Now, what sort of functions lead to asymptotes? Right, well, the classic is a rational function, a fraction function. Now, chapter 5 of your textbooks, section on rational functions, we're going to go into this in way more depth. But just for now, you'll notice that on page 9 and 10 of chapter 1, page 9 and 10, asymptotes is looked at, and it's in the context of domain and range. So all you need to know at this stage is that this sort of function leads to an asymptote. And when I'm sure you've looked at this before, and you probably know what's going to result. When x is 1, y is 1. When x is 2, y is a half. And as x gets larger here, obviously y gets smaller, but never quite gets to 0. So that means, we have this asymptote situation down here on the x-axis. All right, so this here is an asymptote. Asymptote. There's like a little p in there that's silent. All right, this is the x-axis, and the asymptote is y equals 0. So that's the equation of the asymptote. And on the vertical axis, the vertical asymptote, we call this we always look at what sort of asymptotes we've got. This is the horizontal asymptote, and we also end up with a vertical asymptote here, because as x gets smaller, y gets large, but never gets never gets larger without bound, if you like. So it never and x can never equal 0, so we can't ever get in close to here. So this is our vertical asymptote, with the silent p, and it's at not y equal to 0, but x equal to 0. Vertical lines have equation x equals. So x equals 0 is our vertical asymptote. We've got another branch down here, and we saw when x is negative, we're in this quadrant down here. Now when the numerator is negative, so minus 1 over x, it would be in these two quadrants, but the asymptotes would still be at 0. Now, don't need you to know a lot more than that at this stage. I'd like you to know how to use the calculator. So you go in and you go to your main page, open up a graph, and for this we're gonna look at the fraction 1 over x and see how that looks. And we can see there, look at that line, that blue line approaching the y-axis and the x-axis. They're the asymptotes are the lines that they don't quite touch. Now I just want to have one little look here. Just change 1 over x, and we'll make it, and the denominator will make it x. Should we say minus 1? And just see how that moves it around. You can see that just shifts it along to the right. So from your graph, you just need to see, okay, that looks like it doesn't draw the asymptote in for us. We kind of see that it's a vertical one at x equals 1, and that makes sense down here because it's wherever our denominator equals 0. Because we know that we can't divide by 0, or that we don't get a solution. So in this case, when x is equal to 1, I'm trying to evaluate. I'm trying to put a point down here on my graph, but I can't because when x is 1, I'm trying to divide 1 by 0, and I can't do that. So same for this one here, 1 over x. When x equals 0, y equals, I don't have an answer, so I can't plot the point. That's what gives us this hyperbolic type of graph. That's what gives us the asymptote. That's what gives us this break in the graph. It becomes discontinuous because of that. So rational functions. Rational functions are fractional functions. They lead to asymptotes. So going back to our as we change our value of the denominator, our asymptote, our vertical asymptote moves around. Okay, if we change the numerator, it will also move around. But I just want, might just put a 2x in at the top here and see what happens with that. Hit enter, And you can see, oh, that changed my horizontal asymptote around as well. I can see my vertical asymptote. There it is at x equals 1 again. Remember, that's quite an easy one to see. It's wherever the denominator is 0. Now, the horizontal asymptote, in this case, gee, it looks like it's going through 2. That comes from that 2 there. I'm not going to go into any more than that, because in tomorrow's functions test, you're going to have a calculator, and you're going to be able to look at it and determine from your graph on your calculator what the asymptote is. We'll go into way more detail in Chapter 5. That's one to look forward to. I'll see you tomorrow.